Hello, today we are going to discuss Dijkstras shortest path algorithm. Here you can see a graph and a matrix, and in this graph we have to find the shortest path from A to Z, where A is the starting vertex and Z is the ending vertex. So you have to find a path from A to Z. Initially you have to draw a matrix as shown below, and in the first row you are writing all the vertices, and since you have to start from A, the initial vertex is given a value 0, that is starting vertex, and it is enclosed in a square, and a tick mark is given to show that it is the latest permanent label, and other all temporary labels are marked as infinity. And in the second step you have to find the shortest path from A, and you can see in the graph there are two ways from A through B and through C. Through B the distance is 4 and through C distance is 2. And in Dijkstras algorithm, as you know, there is a formula to find the path, that is minimum of old label of j, old label of I plus dij, where dij is the distance from old label label I to label j. And here the I is A and j is B and C. We have to move from A through B or through C. So using this formula you can find out from A the distance to B and the distance to C using this formula. Okay, and when you apply this formula, the old value of B, you can see from the matrix, the old label of B is infinity and the value of A is 0. So infinity, 0 plus distance from A to B, that is 4. So minimum value of infinity, 0 plus 4 will give you 4. And you can see in the second row the value of B is 4. Similarly you can find value for C, where old value of C is infinity, old value of A is 0 plus distance from A to C is 2. So infinity, 0 plus 2, which will give you value 2. And see the second row the value of C is 2. And all other values are of D, E and C are marked as infinity because there is no path from A to all those vertices. And in the second row of the matrix you can see we have got two values, 4 and 2, and from these values the smallest value 2 can be taken as next permanent label. So 2 is enclosed in a square and a tick mark is given. And in the third step, see, C is taken as permanent. Now we can start our traversal from C, and as in the graph you can see there are 4 adjacent vertices for C. That means the neighbors of C are A, B, D and E. Each of them are given with a distance. And since A is already marked as permanent, you cannot take A. So you have to take B, D and E. Here you can find you can use the same formula, that is from C to B means old value of B, which is 4, now the value of C is 2 plus distance from C to B is 1. So 4, 2 plus 1, minimum value of 4, 2 plus 1 will give you 3. And similarly you can use the same formula to find D and E. And in the third row you have got 3 new labels, that is 3, 10 and 12. And from this the smallest value 3 is taken as permanent label, given a tick mark. And in the fourth row you can see 3, since we have taken B as permanent label, we can start our traversal from B, and in neighbors of B are A, C and D. In this A and C are already permanent, so we cannot take them. So we will take D. and we have to find the path distance from B to D. So you can use the same formula in the fourth row. You can find that the value of D is calculated as 8. How will you get 8? The old value of D is 10, comma, the permanent label value is, which is enclosed in blue square. Permanent label is enclosed in blue square. It is 3 plus distance from B to D is 5. So 3 plus 5 will give you 8. And when you compare 10 and 8, the minimum value is 8. So you will get 8. And this row, the permanent label is 8, which means the vertex is D. Now you can start from D. From D you can see there are two vertices remaining, E and Z. So you can find values for E and Z using the same formula, and you will get values as 10 for E and 14 for Z. And from this you can select the smallest value 10 as permanent value. That means the label E. Then you can traverse from E and you will get from E to Z, the value will be 14. So we have completed our traversal, because since we have to find traversal shortest path from A to Z, we have obtained the permanent value of Z is 14. Since Z, last value of Z 14 is enclosed in a blue square and it is given a tick mark, which implies that from A to Z, the shortest distance is 14. So this is the objective of Dijkstras algorithm, shortest path algorithm. Okay, you have to find shortest path from a vertex to another vertex. But since now we have found only the shortest distance, now we have to find the shortest path. You can see on the right side of the matrix some arrows and some letters. That is, you have to start from the last row and last permanent label. That means the Z. I have given an arrow and I have written it Z. And moving upward, you have to find from which row 14 value changes. So moving from 14 to up, you can see the next level there is no change to 14, and in the next level 14 is changed to infinity. From the last it is changed to infinity. So in that row you have to check which is the label that is given permanent value. Permanent value is given to 8, which stands for D. So I have written D. Then in the next level you have to check when the 8 changes, that is value of D 8 changes. 8 changes in the next upper level, and in that level you have to find the permanent label, which is 3, which is the vertex B. So I have written B. And in the next upper level the value of B again changes to 4. So in that row, that means the second row, the permanent label is 2, that is C. So I have written C, and in the first row the permanent label is A. So in the right side I have marked the vertices as Z, D, B, C and A. So in the graph, see, listen, in the graph you can traverse from A to C in the same order. In the matrix on the right side I have written in the order A, C, B, D, Z. So in the graph you have to traverse in the same order, that is from A to C, that is 2, from C to B, that is 1, then B to D, that is 5, and D to Z, that is 6. So we will get 2 plus 1 plus 5 plus 6, which will give you 14. So we have found the shortest distance from A to Z, the shortest path from A to Z using Dijkstras shortest path algorithm.